I'll give every student an opportunity to copy the question on the board that we may discuss it. This is the question. The reaction scheme shown below outlines a method for preparation of fertilizers. So the flowchart is on the board. Kindly take a minute or less and draw it. Then let's discuss it, because the reason why I'm saying take a minute and draw it, because I want to wrap it so that we discuss it. You'll be looking at a copy that you have, as I also look at mine. So just quickly copy and let's discuss the question. The first, the reaction scheme shown below outlines a method for preparation of fertilizers. We have air, element A, element B, natural gas, Haber process, ammonia, fertilizer C, catalyst E, colorless gas F, oxygen, and that. We'll draw the flowchart very fast that we may discuss it. It's good to be quick, so I hope that the majority of you have drawn it. So let's discuss the chart. The reaction scheme. One of the things to note when you are given a chart is to note these directions. These directions, they are key. They are guidelines. So what you want. You are not supposed to answer any flowchart question before you feel what is missing in the flowchart. And you'll only be able to feel it if you keenly note the direction of these arrows that are here. Number one, we have air, and we are told from this we go to element A. From element A, we are coming into a Haber process and we're forming ammonia, natural gas, element B, and all that. The guideline, or rather, the route to this question is here. We know that this is ammonia, NH3, and we are told that what leads to this is a Haber process, and we know that ammonia consists of two elements, nitrogen and hydrogen. So the formation of this gas comes from these two, nitrogen gas and hydrogen gas. We are told we have element A and element B. How will we be able to differentiate, or rather to say that this element is either hydrogen or nitrogen? The guideline is this: air and natural gas. In my previous class, I had said we had met a question asking about the sources for nitrogen gas and the sources for hydrogen gas. And one of the main sources of nitrogen gas, we said nitrogen gas comes from natural gas. This natural gas, I also said, it is a gas called methane gas or steam. I also said that the source for nitrogen gas is cracking of long chains of alkanes and all that. So the source for that is the source for hydrogen gas. Hydrogen gas comes from natural gas, and nitrogen naturally it is obtained from the air. You know that air is a mixture of gases. We have nitrogen, oxygen, CO2, and the rare gases. So we are able to obtain nitrogen gas from the air, and we are able to obtain hydrogen gas from the natural gas. So when these two comes and meets at this point, and Haber process takes place, so we have nitrogen gas and we have hydrogen gas. when they meet, or rather react in a process called Haber process, in the presence of a catalyst called finely divided ion, we end up forming ammonia gas. So we are told this ammonia gas, when you take this direction heading to fertilizer C, before you get fertilizer C, just along the way something is dropped to this gas. Something is added to that gas, and that thing leads to fertilizer C. Then also downwards is simply ammonia plus oxygen in the presence of this catalyst. We form a colorless gas F, and this colorless gas F, in the presence of oxygen, we form a brown gas. This brown gas, when you add water, we end up forming nitric acid, and this nitric acid plus ammonia, this is still ammonia gas. We are adding nitric acid, we get a fertilizer. They want us to identify what is missing in this bracket. So number one, we have said that this element is nitrogen, and this element is hydrogen. Hydrogen, when this undergo Haber process, these two, we end up forming ammonia gas. When you add ammonia, phosphoric acid to ammonia, we end up forming ammonium phosphate. Ammonium phosphate, that is NH positive 4 combining with a phosphate. What we will have is this ammonium phosphate is NH4 times that 3 PO4. It's a fertilizer, ammonium phosphate. Ammonium phosphate. Downwards, when you burn ammonia in air, when ammonia is burnt in air, minus a catalyst, in the absence of catalyst, we don't use this catalyst here, then we end up forming nitrogen gas and steam. But in the presence of a catalyst, and that catalyst is platinum rhodium, we end up forming, instead of nitrogen gas, we end up forming nitrogen 2 oxide gas and steam. So if you see a catalyst here, and this is oxygen, then the equation we are going for is this. So that means that this colorless gas F is NO, nitrogen 2 oxide, and this catalyst here is platinum rhodium catalyst. Now we have NO again being exposed to air, that is oxygen, NO plus oxygen, we end up forming nitrogen 4 oxide gas. This is the brown gas, this NO2. When you add NO2, we are adding water in the presence of air. The next thing we form is this. When you add NO2, nitrogen 4 oxide gas, when it is bubbled in water, you get nitric 3 acid and nitric 5 acid. Nitric 3 acid, this is very unstable, and nitric 5 acid. But they have said there is air, there is enough air, so this air will simply oxidize this to what? To nitric 5 acid, and that's why at the end of the day we are getting this nitric 5 acid. We are not having the 2 acids because as we add water there is also oxygen. So we end up forming nitric 5 acid. The nitric 3 acid will be oxidized in the presence of this air to form nitric 5 acid. When nitric 5 acid and ammonia gas react, when nitric 5 acid and ammonia gas react, this gas, ammonia gas and nitric 5 acid, we end up forming ammonium nitrate. Ammonium nitrate. That is NH positive 4 and the nitrate ion, this and this, that is 1, so we end up forming ammonium nitrate. So this is also a fertilizer, this one. So this fertilizer here is ammonium nitrate. That is NH4NO3. I think I've answered all the question. What is element A? Nitrogen. Element B? Hydrogen. What is fertilizer C? We had said that when ammonia and phosphoric acid react, we end up forming ammonium phosphate. Ammonium phosphate, and ammonium phosphate is NH4 times 3 PO4. Where is D? Fertilizer D is ammonium nitrate. This is the symbol. E, there was a catalyst here, and that catalyst, platinum rhodium catalyst. Colorless gas F is nitrogen 2 oxide, NO. Nitrogen 2 oxide. When nitrogen 2 oxide is exposed in air, it is oxidized to brown gas, that is nitrogen 4 oxide. When you add water to brown gas in the presence of air, we end up forming nitric 5 acid, or nitric acid, nitric 5 acid. So I think I've answered all the questions.